Hi, welcome. To start today, I'd like you to write some multiples of 6 down and write some multiples of 8 down, and then think about the other questions. Circle any in common and which one is the lowest one. Pause the video, try this out. So some multiples of 6 is 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, so on. Multiples of 8, 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, and so on. Now I've only written 5 down, and in this case we've only got 24 that is shared in both. So these are common. And furthermore, this is a multiple of both that they have in common, and it's the lowest one. And that is the definition of the lowest common multiple. So the answer here is 24. Now, sometimes it's not quite as simple as this. If I start writing down numbers like 112 and 256, that is not as easy to write down the times tables and easily see the lowest one that they share. So we perhaps need another method, which is what we're going to look at today. And here we are again, back with Venn diagrams. So this is an example. Find the lowest common multiple of 6 and 8. Well, we've just done that actually up here. It was 24. But how can we do it using a Venn diagram method? Well, it comes back to writing the numbers as a product of their prime factors. 6 is 2 times 3, 8 is 2 cubed. We can then fill in this Venn diagram like we did before. We've got a shared factor of 2, so I can keep track of it, and then I'm going to be left with 3 here and 2 2's here. That would be what it would look like. We get a highest common factor of 2, but what about the lowest common multiple? Well, if you do 3 times 2 times 2 times 2, then actually you get 24, and that is how you can work out the lowest common multiple. So I've kind of answered this question for you, but you multiply all the prime factors. That's not quite right. All the prime factors, but you have to sort of account for the shared ones. All the prime factors in the Venn diagram. Now, you might be thinking, and I hope you are thinking this, like, how on earth does that work? Well, here's how. So I'm going to write down, I know, for example, that 6 times 8 will give me a multiple of 6 and a multiple of 8. By definition, it must do. So that will be a multiple of both, a common multiple, and I could write that as 2 times 3 times 2 times 2 times 2. Now I can see that, for example, my 6 is here, so that's definitely going to go into this number. And the 8 is as well from here, but actually I don't need that extra 2 because this 2 times 2 and this 2 from the 6 will already give me the 8, so I don't need that, and that's why it's not going to be 48, which is 6 times 8, it's going to be 24, because I have to divide 6 times 8 by 2, because I've got this shared 2. That was one explanation, and you can see, so if I got rid of that now, you can see when I have my 2 times 3 times 2 times 2, I can make the 8 from the blue parts, and I can make the 6 from the red parts. Let's go through another example, and I'm going to give like another kind of method that you can use as well. So I want you to try this one out. Can you find the lowest common multiple of 140 and 220? I'm saving you time here. I've given you the prime factorization. Remember, you would potentially need to find this yourself. What do you then do? Pause the video, try this out. Well, I've given you a little bit of a hint even with these shared bits here. So what you would get is a 2, another 2, and a 5 in the middle, because these are the shared factors. And we'll be left with a 7 over here and an 11 over here. So then the lowest common multiple is going to equal 2 times 2 times 5 times 7 times 11. I've written it in order. You could write that in index notation as well. 2 squared times 5 times 7 times 11. You might be asked to do that. Let's just check that works then. So I can see in red, whoops, that was meant to be in red. In red, I've got my 2 times 2 times 5, and I got the 7. So that's going to give me the 140. And then in green, I've got the 2 times 2 times 5, and then I've got the times 11. So both 140 and 220 are going to go into this number, and I couldn't make it any smaller because if I get rid of any of the parts, they wouldn't go into it. Hence, this is the lowest common multiple. I'm just really trying to explain, help you understand why this works. Why can we do, because if you just remember to times the ones all in the Venn diagram, you haven't quite understood the maths, you've understood a method. So I'm trying to explain where it's come from. So highest common factor are the shared ones, and I hope that makes sense because we're timesing the middle ones together. We can see that they go into each number, and when they times together, they'll still go into each number, and there is no other extra factors that go into them, so that must be the highest common factor. For lowest common multiple, we times them all. We just don't count the shared, well, we just count the shared ones once because we don't need to count them again. In fact, they would give multiples if we times them by them again, but not the lowest common multiple. And I've sort of talked about why. Because if I added an extra 2 and an extra 2 again, they're just not needed. Yes, you could create, instead of an extra 5, you could create the 220 from this bit here, but you don't need to because you can already use the 2, 2, and the 5 from here, so they're gone. Hopefully that is making sense. Right, I'm going to test you now then. What is the lowest common multiple of 72 and 90? So it's up to you, but you could draw a Venn diagram here. 72, 90. Write the shared ones. We've got a 2 in the middle, a 3 and a 3. And 72, we're just left with another 2 and a 2. For the 90, we've got the 5. So the lowest common multiple, we're going to times them all together. If I do 5 times 2, that's 10. Then times it by 9, that's going to give me 90. 90 times 4 is going to give me 360. This one you might have done perhaps by listing, but just trust me, there are more complicated questions. If I just gave you the prime factors, then that would also be a good way of doing it. Going to get you to do some practice in a second. I just want to talk about one other way that you could write your answer down, and it's equivalent, and it's actually how I do it. The Venn diagram is really good, but sometimes I like to save time and not even draw the Venn diagram. So here's the other way you can do it. I can write down for 6 and 8, I can write down 6 is equal to 2 times 3. Actually, I'm going to leave a little gap there. Sorry, let me try this again. 6 is 2 times 3, but I'm going to line them up. I did this before for the highest common factor. So line them up, and then I'll put the 3 in. Now for the highest common factor, I said that we circle the shared one, and then that would be the highest common factor. For the lowest common multiple, we circle it, and then we circle the other ones, perhaps in a different color, and then we times those together. So it's just going to be 2 times 2 times 2 times 3, which is exactly what we got before. It's a way of dealing with this, but not having to draw the Venn diagram. I'm just accounting for this 2 once, and then I'm timesing by the other ones. So that is a neat method, in my opinion. And I can do exactly the same here. I can write down, actually I've got them here. I could write down 140 is equal to 2 times 2 times 5 times 7. And that 220 is 2 times 2 times 5 times 11. And I'm not lining the 11 up with the 7. Circle this and this. and this, I can see the highest common factor in there. And then I just need to times by these as well. So 2 times 2 times 5 times 7 times 11. Again, it's the same thing, just a slightly quicker way. If I got the prime factorization, I don't need the Venn diagram. You can even go one step further and just, I can see that the highest power of 2 is 2 squared. The highest power of 5 is 5, and then I need the 7 in there, and I need the 11 in there. You don't even need to write them out like this. You can just go for the highest powers, because that's ultimately what's going to happen when you write it out like this. And here, for example, I can see the lowest common multiple. Well, 2 cubed is the highest power of 2, and I need that 3 squared. So you can actually do these questions really quickly if you understand this and can get accomplished with this method. So onto some practice. This is actually the same task as I gave previously for highest common factor, but now I'm asking you for the lowest common multiple. So if you've already got your Venn diagrams drawn, feel free to use them. You don't have to draw them from scratch. Otherwise, you should show enough detailed work in. And I think in general, you don't want to be just writing down the times tables. You might get away with just like looking at it and guessing for the highest common factor, but I think the lowest common multiple, with it being much larger, especially for ones like this, 108, 162, much better to use this approach that I've given you. So pause the video, try these out, then I'm going to show you the answers. So for 36 and 90, 180, actually not too bad. 56 and 84, 168. 54 and 135, actually they're working out quite nicely, but this is kind of lucky, I think. Oh, they just happen to be in that times tables. It won't always be quite so nice. So please do try and understand this method. You get away with it here, just writing the few down. Less so, I think, for A and B here. 2 cubed times 3 times 5 squared. And then this one, 2 to the power 4 times 3 to the power 3 times 5 to the power 3 times 11. 297,000. You wouldn't be writing down the times tables of that. So a few things just at the end to test you with. 48 and 36, can you write down as a product of its prime factors the HCF and the LCM? Not interested in the actual number that it is, or any of them are. We just want to know the prime factors. So here's the answer for the HCF, 2 squared times 3. We can see that that's actually the lowest power that goes into both for the 2's, and we need the 3 in there. If you line them up, or if you did the Venn diagram, that's what you should get. And then for the lowest common multiple, it's 2 to the 4 times 3 squared, because this is the highest power here, and here's the highest power for 3. Another one. This is what we get for the answer. So make sure you can deal with this sort of question. And then finally, a challenge question. What if I gave you 3 numbers and asked you for the product of prime factors, and could you then work out the HCF and LCM of these 3 numbers here? Well, what we get is 48, 90, and 150 as shown. And then a hint is to draw a Venn diagram of 3 overlapping circles. If we do that, we've got the shared factor. Well, I've got 2 as a shared factor. I've got 3 as a shared factor. And then the 2's just go with the 48, and they're not part of the 150 or 90, so they would go here. There's, however, a common factor between 90 and 150 of 5, so actually I'd put the 5 here. And then there'd be an extra 5 by itself here, and an extra 3 here. Highest common factor is 6, 2 times 3. The lowest common multiple will be if I multiply all of these together. So I'm accounting for the fact that all of them have got 2 and 3 as factors, but then 90 and 150 have got a shared 5 here. So I actually just times by 5 twice overall, even though there's 3 here and there's none here, because I don't need to account for that one because I've kind of already accounted for it. We could maybe, I think just to demonstrate, I'll write that down. And you get 3,600. If I write down 2 times 2, okay, if I write it all down, so let me look for the 2 times 2 times 2 times 3. I just get that here. That's my 48. I can see that 48 goes into it. 2 times 3 times 3 times 5. Here we go. That's the 90. And then if I want the 150, I need that. I've got, oh, sorry, I think for the last one, I didn't quite do it right. 2 times 3 times 3 times 5. I didn't underline the right thing. So it would be this actually. Ah, there we go. And then for the last one, 2 times 3 times 5 times 5. So I could do the 2 times 3 here and the 5 times 5. So you can see that all the numbers go into this lowest common multiple. And furthermore, I can't make it any smaller. I can't get rid of a 5 because I need 2 of them. I can't get rid of a 3 because I need 2 of them. And I can't get rid of the 4s because I need 4 of them. Just to summarize then, if you're doing the Venn diagram approach, highest common factor is a product of the common prime factors. It is the intersection. Make sure you know that. Whereas the lowest common multiple is all of them. It only includes the common prime factors once. We put them in the intersection. Okay, well done on this. It's it can be a little bit tricky at times. I'm tried really hard to explain why it's the middle and why it's the outside. I hope I succeeded. Thank you.